record. It's going. All right. Welcome, everybody. Tonight is the 30th of March. The first quarter is almost behind us. This is Dallas Personal Robotics Group Builders Night Virtual. And we're going to hang out like we usually do, go around the table, talk about mostly robot-y things that float our fancy or float our boat in the canal, whatever happens to be the analogy, the fails of the night, or whatever suits our fancy. So with that terrible lead in, does anyone in particular want to lead off with what they've been doing in the last week? Flooded basements, robot control of the humanity, anything like that?
Since
Chris,
I have to go
excellent.
early, I'll start early.
Go, okay, we're going to follow the sun from east towards the west, whatever that means, when somebody's 12 and a half hours away. So go ahead, Chris.
All right, just a fairly brief Wordle update following from last time, not yesterday. So I talked a little bit about what I was doing on my Romy platform. I showed a picture the last time about, I'm hooking up these ultrasonic sensors, right? These little guys. And was hooking them up to the STM32, to my green pill, black pill thing. And I think I mentioned what I'm trying to do is basically use it as an I/O slave and just stream all the data that I'm collecting over to the Pi, right? Analog inputs, ultrasonic ping, timings, and so on. The B&O is also connected to my STM, so I'm collecting the IMU data. Now, I did have a little trouble getting this one to work in single pin mode. I mean, this is the 4-pin version, but I've previously used it in single pin version. I meaning, tying the trigger and the echo pin together, and then just playing some games with the pin on the micro. Switching the pin between input and output, so you can produce a ping, right? You can produce a trigger, and then you're switching back to input mode, and you're waiting for the echo. That sort of thing. That worked fine on the Atmel. For some reason, it wasn't getting it to work properly on the STM32. Again, maybe a 3.3 volt, 5 volt interfacing thing. This guy really wants 5 volts, to operate at 5 volts, and then the STM will tolerate that, but really wants 3.3 volt signals. So, in absence of a scope, I couldn't really tell what was going on the wires. But long story short, I couldn't tie the trigger pin and the echo pin together outright. I had to tie them together using a resistor. And so again, I don't have a scope right now, so I don't really know what's going on the wire, right, between when I produce a trigger signal and then turn it back into an input and wait for the echo pulse to come back that I need to time. I don't know what the voltage levels are doing, but when I tie the two pins together and connect it to an STM32 input/output, right, toggling, it just wasn't even producing a ping. So again, that stumped me a little bit until I just tried a few different things ad hoc, because I don't have a scope, and so a resistor between trigger and echo pins seemed to do the trick. So I'm gonna have to follow up there. I want to know why that helps. I really need some scope, and I know you guys recommended a couple cheap USB ones the other day, so I really need to get me one, because it's really hard to, as I'm getting, I never had to deal with 3.3 volt stuff in the past, so it's really only as of recently that I'm mixing 5 volts and 2.3 volts. I just feel that's going to get me into trouble again and again, so I really need to get me a scope. But in the end, it was working, so I have a setup now where I can ping 2 sonars. I'm going to expand it probably to 3 or 4 of these sonars and just stream the data over. And I think I previously mentioned that the way I'm going to do it is just to dump it over the serial or virtual serial over USB, either way, as plain ASCII, humanly readable, just comma separated values, just to keep it simple. Now, then I thought, okay, before going down, my own path, I wanted to take a look again at something that already exists. And so I did take another look at Fermata, which I had done many, many years ago. And I didn't remember why I didn't like it, 5 years ago or 6 years ago. So I had to look at it again. Didn't have any notes on it. So I did look at Fermata again and played around with it a little bit. And so my takeaway is there is something there actually that's useful, I guess, for some people trying to do certain things. Because it's almost like the Arduino or Arduino-like device becomes an extension to your Raspberry Pi, right? Once you figured out the API that you would use in Python or whatever you're using on the Pi, it's almost like you're directly controlling the pins on your Arduino. So there's some benefits there, depending on what kind of prototyping you're doing. But it wasn't really fitting my use case. I found the API a little convoluted and just not to my liking. I really just wanted, because I knew exactly what data I want. I just, at a fixed rate, just give me all the data. Just give me all the analog inputs. Give me my sonar pings at a fixed rate. Just fairly straightforward. But with Fermata, it's really designed to be very, very flexible, right? And so with that flexibility, I found it in the end just not really working the way I wanted it to work. And the other thing was I found that on my Raspberry Pi, when I had things going on, so I was just receiving a couple analog readings from the Arduino. So when I say Arduino, I mean in this case my black pill running sort of Arduino framework code. So I was receiving a couple signals, maybe one digital input, a couple analog inputs, and that consumed 25% of the CPU on my Pi. I mean, one full core basically out of the 4 cores. What the heck is going on here, right? So that just doesn't make any sense. Now, again, because I didn't like the API anyway, I didn't feel like getting to the bottom of that. Maybe I was sending the data a lot faster than I needed to. I mean, again, I wasn't really using a serial connection. I was using USB with virtual serial on top of that. So you're really not constrained by any actual baud rates, right? You can send data across at whatever speed USB will allow. In this case, it's 12 megabits, and as fast as the STM can send it. But I'm pretty sure it was configured for a certain update rate not exceeding 1,000 hertz, which, or actually the default is even I think 19 milliseconds or whatever, 20 milliseconds or something for the analog readings. So I don't know what was going on behind the scenes, but 25% of a Pi consumed just by receiving 5 values, just kind of ticked me off. And then I said, nah, that is not working out for me. But again, there's, I think, something there for some people who need to constantly reconfigure their hardware, maybe, because if 1 minute you needed something to be an output and twiddle something, and the next minute you wanted that to be an input, right? And you're just kind of rapid prototyping that way. I think Fermata is perhaps a useful tool. And it does come with libraries on the Pi. It does even come with some user interfaces. I didn't play with those, but there are some user interfaces out there that'll give you basically the list of inputs that your Arduino has, right? And you can then reconfigure those and play with those, and use it as an I/O extension to your Pi or whatever else you have as a host. So I gave up on the Fermata and then went back to my keep it simple kind of ASCII streaming that I'm probably going to stick with, given the extra bandwidth I have available on the USB link that I plan on using, and given that the STM has plenty of performance. So it doesn't matter if I'm sending across twice as many bytes as I technically need to send across the link. So that's what I plan on sticking with. And yeah, so I have those 2 sonars working, basically getting pings and echoes, and next step will be to actually tie that in with the rest of my logic that I previously had going on, line following and other things, and remote control from the from the web interface. So I do want to tie that in somehow, and hopefully at some point have a little bit of semi-autonomous thing going on. Again, something I've never tried before, but we talked about, right? You have a remote control, you're doing interactive, but then obstacle avoidance kicks in so you can't crash it, right? So just that kind of very basic behavior is what I want to do next, to see how that feels, right? How I want to experience that operation just to see if that's useful. Because again, in the past, it's always been, well, either it's fully remote controlled, right, or it's fully autonomous. But I've never actually tried anything in between where I'm controlling it, but it does, it does sort of obstacle avoidance, as it gets too close to stuff. So I'd like to see how that, how that feels.
Hey, Chris, that's actually exactly what I've been trying to do. And I've had this little Bluetooth controller. And so what I've done in the past was use this to manually control the robot. But then if I just take my hands off this thing, the idea was the robot would then avoid things. And so I had one behavior that as the robot's center analog infrared came up upon something, it would gradually slow down until it got to the point which was set in configuration that the robot would just simply stop. So it couldn't get any closer than that particular fixed distance. And
right.
Then I could back, and then it would sit there not doing anything, and then I could back it away with the Bluetooth. I did have one thing I was going to add in terms of Fermata, is that was what I played with about a year ago, I guess, although maybe longer now when I think about it. But I had gone ahead and I was using a 5-volt Arduino, and then went ahead and bought, I pulled it out of the cupboard. It's one of these, it's a Nano 33 cents. It's a 3.3 volt Arduino. The idea being is that it would have the same pin logic voltage as the Pi, and therefore I could communicate directly between them. But as a small caution, it turns out that the Wire I/O library was never ported to be compatible with this thing. Someone didn't even bother. It's like a major library, and they didn't port it to be compatible. So I couldn't run Fermata on this because it doesn't support the Wire I/O library. So,
but Fermata relies on serial only, not the wire, right?
I think underlying everything, it has a Wire I/O dependency, if I remember right.
Yeah, well, I mean, it probably does, because you can access from the Pi I2C devices that are on the Arduino. So Fermata has a mechanism for kind of that indirect I2C setup. But I was thinking you could probably disable that, because the Fermata connection to the Pi, right, would be just standard UART, or some sort of serial link, whether it's a virtual one or an actual UART link. That it's not an I2C link is what I'm saying, right?
But I was actually using an I2C link. That's why.
Okay.
But I just
so that's it from my side. That's all.
Cranking along. Very nice. Who else has had some good luck this week? Nobody. Everybody's chasing flooded basements.
And crashed Macintoshes.
Oh no, crashed Macs.
I got a 12-inch MacBook, one of those little tiny MacBooks that I bought brand new about 3-4 months ago, and old stock, and it died the other day, and there's no account on it at all, and so I've tried. It's sitting there right now, spinning away on its 3rd or 5th or whatever attempt at reinstalling the OS, and it's just, I think the SSD died or something. But since I'm already gabbing away, I'll give an update. Let's see now. What am I doing? I'm starting on my Mecanum robot because I've actually got all the parts for it. So the guy that runs Fortronics went ahead and changed the firmware. And so I've got 2 PyCon Zeros mounted on a Pi 0W with a little board between. And it's nice and compact. So that's the whole computer with 4 motor controllers and looks to be about a dozen servo connections if I wanted to plug servos in. And I've got my Mecanum motors, and I'm starting to lay out pieces of 3mm plastic and just kind of starting to put it together, because it's just one of the sort of side things, because I'm still working on my asynchronous message bus in Python, which is tricky. I'm almost done. It actually works. I've got it now where I can hit keyboard buttons that simulate events coming off the sensors, and it does respond properly. And I'm just now starting to attempt to wire it actually into real sensors. But it's, I'm not a master Python programmer, and doing asynchronous I/O stuff in Python is pretty tricky. And I also have a goal of there's different kinds of message buses, and one of them, it's all about guarantees of messages, and this is The one I'm trying to do is where every single subscriber to the publisher has one access to the publisher's message, and that's it. And then it gets thrown into a garbage collector. So the idea is that you have a guarantee of any message being sent by a sensor. All the subscribers can say which types of events they're interested in, and if they can ignore an event or they can consume it. And if they consume it, it gets put back on the message bus after they've consumed it. And then it finally goes to the last of the subscribers, which is a garbage collector. And that all happens asynchronously. So it's getting there. Hardware wise, I've had a number of like MacBooks and things crashing. I've managed to get, what was it? I've got all of my hardware up and running now with 64-bit Raspberry Pi OS. It's a beta, and I've managed to pull across all of my code, and the PigPio library is one of the main libraries on the Pi for doing GPIO stuff. And it turns out that that is 64-bit compatible now too. So everything is 64-bit now. And I've managed to figure out how to copy SD cards and, you know, all that kind of stuff. So it's all this sort of, I don't know, housekeeping, I guess, like sweeping the sawdust out of my basement, soggy sawdust, that kind of housekeeping. So, but that's it for me. No big splashy stuff yet. My asynchronous message bus is the almost to be released news.
That sounded pretty good.
Well, it keeps me busy anyway. So,
Can you put a link or what's the name on the hardware, the compute platform for your Mecanum?
huh? Oh, you mean the Fortronics? It's just Fortronics. Fortron, the number 4,
Yeah.
Tronix, Fortronics, and it's a UK company. Nice little company. They do the they do that Mars lander thing with a Raspberry Pi Zero.
Huh.
Fortronics Co. UK. I'll put it
Okay.
into the link. I mean, into
Cool.
the message. They make a little tiny Raspberry Pi or microbit controlled Mars rover that's built out of PC boards. It's pretty cool.
All right.
Yeah, and they're really nice people. It's a small company. I highly suggest we support them because he does good stuff. I think, I'm not sure where the boards are actually made. I think they're actually made in the UK. And I've been using this PiCon Zero, which fits right on top of a Raspberry Pi Zero and gives you, I think, 1.5, I can't remember, like 1.5 or 2 amp motor control. And they make a whole series of small robots that might be good for clubs. So, and I'll put that into the link.
Cool, thanks. Right?
Can I go next?
Go for it, John. What you got?
Yeah, so finally I got, I heard Chris was mentioning about 3.3 volts. So this is my 5 volt to 3.3 volt board that I had to make because of this divider for my wireless. This is the wireless serial. But yeah, finally it's out. It's been a roadblock for me. But basically this is the circuit that, I don't know if you guys can see this, but it looks similar to a breadboard, and I mean it's a lot easier than the single point connection. So that's the main achievement. The other thing, I got Pfizer last Sunday, and I think many of my colleagues, quite young, are getting the shot, so it's a good thing. Yeah, that's my main update.
That's not cool.
So you haven't grown any extra appendages?
Yes. Do you have any side effects? Was your arm sore?
It's been 2 days.
Okay.
Yesterday was a little sore. Today, very tiny. I mean, yesterday was, I raised it, I would feel a little hard, but I mean, it's not an issue at all. But today,
So
it's just not a problem at all. Still
I
feel something.
So did you get the Pfizer or which one?
As much as
Pfizer, yeah.
Okay.
I'd gotten the Pfizer. Neither I nor my wife had any reaction.
Yeah.
Yeah, I
In
had
my
the Pfizer,
case-
and
Yeah.
it wasn't really sore, but after 3 or 4 days, I started to get this kind of pain, a really goofy rash on my wrists, both wrists, Yeah. And it's not unique. There's apparently a handful of people that get it now and then, but
Okay, I'm
if that's
not
the
through
worst
for
that comes
this
of it,
yet.
no problem.
Yeah.
So did the rash go away then
Okay.
Yeah.
after a day or two?
It took about a week total to go away.
Hmm.
Oh, okay.
So in
And then
my
they
case,
came out just this
so
last
when I
week
got-
with CDC finding that if you get the first shot of Pfizer or Moderna, you've got like 80% effectivity, efficacy, benefit after a week or two of it, just from the first shot, and then the second one boosts it up to 90 or so.
Yeah, just the first shot is apparently does
Yeah,
a
I
lot of damage.
scheduled my first dental appointment.
yeah, because in my
I mean,
case, I was going
I-
to say, basically the arm was very sore the next day, but not a lot. And then 3 days in, I was basically slept all day. So that's probably why this week I'm still tired. So yeah, I'm sleeping more now.
Yeah, my wife
All right.
goes in for her second tomorrow.
Well,
yeah,
hopefully
one thing I want to
she won't
mention,
have
when I
to.
went to, oh, can you guys hear me?
Yeah.
Is there a long delay? I don't know. I'm using my phone. But yeah, when I went to Fair Park, I got it from Fair Park. I chose to ride Dart. I thought it's a good idea, but I don't know. I mean, because I didn't drive. I saw this long line of cars, but basically between I get off Dart and there's bus. So basically, I got on the bus, and the bus took like three people over to the side, and some soldiers just came on board and gave us short ride on the bus. We didn't even have to get off the bus.
Really?
But
Wow.
it took maybe 40 minutes from the time I get on the bus to I come back. I don't know how long it would take if I drove there, but yeah, I hope I did the right right choice.
Sounds like
Fair
I
Park
had the
from
right
Capel,
choice.
probably at least 40 minutes. Yeah. Does Capel doesn't have Dart buses though, does it?
Oh, it does. I mean, I'm North Capel, so it's like 35 to 121 crossing. It's like the beginning station of the Green Line. So
Oh,
I
really?
ride Green Line
Okay.
all the way down.
Yeah, when I lived in Capel, they said no, we
Yeah,
don't want
pretty
Dart.
convenient.
But so I guess they got it. Yeah, there. But
Maybe it's newer. I mean, it's been there for a few years.
yeah. I moved out in 2008 out here.
I have a
Oh, okay.
follow-up question I'd like to ask Chris. Is this a good time?
jump in.
Chris, you were describing using as sort of as a peripheral I/O node, and then streaming the data, serial over USB to the Pi. And do you do that as a single packet, if you will, for all of the? Let me rephrase it. Do all of the sensors update to the Pi at the same rate?
That's what I'm planning on doing, because in the past, when I've done that sort of thing, more for data collection purposes, when I just had my Atmo controller and I was just streaming the data to the PC for, analysis, I did the same thing in the sense of I was, whatever rate my controller was functioning at, which was 40 or 50 hertz at that time on my firefighting robot, I was streaming the data over Bluetooth to a PC, all the inputs, every control step. And to me, that just keeps things simple. And so I was thinking of doing the same thing between my I/O coprocessor and the Pi, fixed rate. I'm thinking my rate needs to be 100 hertz because, well, the IMU wants to really operate fast. And so, yeah, the idea is to send every 10 milliseconds the full set of data across the wire, which isn't really all that much, right? If you think about it.
But some of those sensors have not changed their state
Correct.
during that
Correct.
analysis.
You're totally correct.
Okay.
So yes, there's some wastage
would-
there. The ultrasonics in particular, right? I mean, they're dead slow, and I'm not planning to be too aggressive with multiple sensors going on at the same time. I would cycle through just to avoid sort of crosstalk. But yes, you're totally right. There's going to be at that rate, right? Especially if I stream at 100 hertz, there's going to be a lot of stuff that's not updating. The only thing that would be updating is, the IMU, analog inputs for sure. If I connect my line sensor array to that, I mean, that would be updating easily at 100 hertz. If I ever have any encoders going on, which right now are on a different I/O coprocessor, so to speak, that comes with the ROMI, right? There you want to read the encoders at a high rate. So, but you're right, a lot of stuff won't be updating, but I don't see an issue with that. I'd rather not sort of send different data at different times and different amounts
Yeah.
of data.
Yeah. So the sensors that are not ready, you just send whatever the last reading was until you get a new update.
Correct.
I know that Murray has kind of hassled with this too. He has a front bumper that's got a lot of different sensors, and he packetizes that and sends it all over at a fixed rate. Yeah, you're right. With the big sonar, you don't know that you didn't get a reflection until 32 milliseconds. It takes you that long to know you didn't get a reflection. So, you're really updating, what is that, 6 hertz or something like that, compared to, as you say, encoders or something like that. So, just curious.
Yeah.
When you pull the whole packet data in like that, do you get a stale flag? Are you able to tell whether the data is new or not, or do you just get the most current value, whatever it happens to be?
So I'm not planning on doing anything sophisticated like that. I mean, I'm thinking it's perfectly fine to just sort of pretend the value is still the same, right? Any control logic that's using the ultrasonics or even some of the IR sensors that I've used before, the sharps, they're not super fast either. I think they take on the order of 30 milliseconds also to sort of really update their output that you're then reading through an analog input. So the way I've operated my control loops in the past, I've just simply ignored that. Whatever the latest value is, I'm retaining that, and I just run my control logic. I just ignore the fact that it might be a stale value. Now, what I am doing with the sonars, sometimes you don't get a response. That's right. That is a problem with the sonars. So I am translating that into like a -1. Okay. So I know that, and I'm pinging them, at a fairly good rate, let's say at 20 hertz or so. Every 50 milliseconds, I would be pinging a sonar. And so if I don't get an echo because of whatever reason, right, it's going to be a -1 immediately. That -1 is going to persist for quite a while, because with these cheap guys, right, it's actually, once you don't get an echo, I mean, you probably know this, right? It takes on the order of 200 to 250 milliseconds for this guy to get ready again, so you can ping it again. You can try. You can trigger it. There's nothing coming out, because you can hear a little click. I put my ear up to it. I can actually hear it clicking. And so when it doesn't get an echo, it gets into some mode where it's going to sit there for at least 200 milliseconds before it lets you ping it again. So once I return a -1, there's going to be a -1 there in my data stream for considerable amount of time, and then at some point I get data again.
Even in that case, though, the controller that's reading those is guaranteed that it'll always get the same size packet.
Right. That's exactly. I'm trying to keep it that simple, same size packet. And again, the only thing that's different from what I've done in the past is this time I'm trying to make it all ASCII, all humanly readable, just so I can look at it also directly.
Chris, do you have a dog?
I do.
You could use him to tell you whether the thing is pinging or not. You know, it's like,
Okay, I got a good idea. Good idea. Although I did have it running the other day, and the dog comes in and out of my office. I'm all right. I need to pay attention if the dog is noticing anything. I need to pay attention. I don't recall any strong reaction from the dog. Let's put it that way.
Oh, the other thing is the trigger active low?
No, it's the trigger is you give it an active high, 10 microsecond pulse, and then you wait for an echo pulse, and the length of that pulse is the amount of time the signal was in the air. And so so it's all active high. The echo is a high pulse, and you give it a high pulse to ping it.
Yeah.
And like I said, it's by switching that single pin between input mode and output mode, you can do it all on one pin. It just wasn't straightforward on the STM32 for some reason.
Yeah. I was thinking if it doesn't make sense if the trigger's active high. But
I really couldn't make sense of it.
Yeah.
Why would that resistor again? I was just randomly trying stuff because I didn't have a scope, so I couldn't see. But I mean, the logic analyzer is of not much help because it'll interpret voltage levels whichever way it decides. I don't know where it sets the threshold, right? So you can't go by the logic analyzer. So I really need a scope for this kind of stuff because I don't know what the voltage levels are at. But clearly, I'm probably, even with my resistor solution, I'm probably operating in a gray area, I suspect right now. Although again, I don't know why. It just worked out of the box the way I thought it should work on the Atmel without any issue. And the same setup doesn't, work the same way on the STM. So
Okay, Chris, are you powering at 3.3 volts?
I'm powering the HCS, that Sonar at 5 volts, because when I'm powering it at 3.3 volts, nice, I need that one. I have an old one, but it's too big and clunky and not much use. So that when I power it at 3.3 volt, that Sonar, I don't think I ever got any echo back. It didn't seem to want to work.
I was going to say, the chip on there is the MAX232, and it essentially has a capacitive voltage regulator on it. Otherwise, what it was made to do was take TTL logic and bring it up to RS232 voltage levels.
Yeah.
Okay, so that's what it was. And the reason they do that is because that high voltage allows them to get a really strong ping out of the transmitter. So if you take it down to 3.3 volts, you may not be getting as strong a ping.
I wasn't getting any proper behavior. Now again, maybe at the same time there was something wrong with my logic. That could be, but I'm pretty sure the moment I switched to 5 volts, it was just working. So I'm not even going to try with 3.3 volts.
I was going to just say that you're right. That's the way to go. The other thing is, I have seen people put a resistor in many times. If you go out on the internet and look at how do I make this work as a 3-pin sensor,
okay,
a lot of them will show a resistor in their circuit.
Interesting.
And I've looked at it and said, oh yeah, that makes sense, but I haven't looked at it in a long time, so I can't remember exactly where the resistor is. And I often said, well, I wonder why they need that resistor. But the other thing too that's a little tricky on these things is they're made by, even though they look the same, they're made by a gazillion different people, and over time they've used different software in their chip. And you can find, you were talking about, well, I didn't get a ping, and you have to wait for it to time out, and it's like 200 milliseconds. Sometimes it's 100 milliseconds. And sometimes they actually have that problem fixed. But you can't buy one and know ahead of time. You just have to get it and test it out and say, okay, this one works, this one doesn't. But you know. And the other thing,
Definitely a lot of variation. I mean, even when I do simple tests like, see if I can detect this pen, some of them will, some of them won't.
yeah,
Or maybe some of them will detect it if it's over here, but not when it's over here. Others will detect it no matter where I put the pen, So even the field of view is a fair amount of variation, but you get what you
and
pay for.
that's because they're selling these things for less than $1, if you look at something like a parallax ping, I think they're like about $25 or something like that. So there's a lot of variation, and like I say, you can't really tell. And there's also a lot of quote versions now, where they have a different number. It's not a HC204. It's called a U something 015 or something like that. And they do have different circuits, but they have the same problem. There's, if you get one from one guy and one from another guy, there's no guarantee they work exactly the same. But if you get a good one, and I've had good ones, man, they work great. And the other advantage is as you know, the closer the object is. So if you're doing something like you're trying to detect an object in front of you, the closer it is, the faster you get the return because it's close. All right, so you actually start sampling very quickly. So you want, then you probably would make your 100 hertz.
No, you can't. I've tried. There's a limit of how fast you can ping one of these, at least the ones I have.
Yeah.
Even if you get your return super fast, they won't. Some of them will let you ping them faster than others. I have not found one that I can ping faster than once every 20 milliseconds. And
Well,
many of them you can't go below 30 milliseconds, sort of.
That's probably about right. Now I'm thinking about it. I know I used to have a robot that on a tabletop robot, and it was using a sensor to find cans. And when the can was far away, you'd watch it, it would just step slowly. And if there was no can, it would really step slow. And then all of a sudden, as soon as you got near a can, it would go ding, 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 real quick because the can was close. Yeah.
Doug, I found that leads to difficulties in the control code. So the code that I've used those with, I actually force it to sample at a constant rate. There's a window, and if the ping comes back before the end of that window, it just eats up the rest of that time before it sends up. And
that's probably a good way, David. I'm just saying that particular robot, that wasn't the way I did it. I'm smarter now than I used to be. But it was because I used to look at it and like, God dang, this is so funny looking. But I agree with you. I'd probably do that too. But I would pick that time as quick as, try to pick a time that would return quickly as the sensor would allow. If it's 20 milliseconds or 30 milliseconds. But some of them will allow you to reping them. Okay.
What?
That doesn't mean that the sound has gone away. Okay.
Right.
So if you pinged it and it's out there coming back, and you ping it again, and then you get the return signal, you can get a squirrely reading. So there's a lot of funny weirdness when you use ultrasonics, but they're so cheap. And
they're not that sensitive, so actually the chances of pinging up an old ping are not that high, I think. But you're right, technically it can happen.
Yeah, it depends on if you're going in.
We were buying these things for like $12 or $15 a piece from Parallax, and then all of a sudden one day, $12 would get you a bag of 10 of them from China.
Yeah,
and that seems to be where all these problems began.
Yeah.
So this is a pair of the Parallax, and they actually sold this cool little. I don't think they do anymore. Can you see that flashing? Yeah.
Yeah.
So, well, over the internet, that's not going to make any sense, but that's the sample rate.
Can't see your image.
And So you're having good success with the parallax?
Yes. Now this is, these were bought maybe a decade ago, and they're 4-pin devices, so there's a separate trigger and echo. I never tried to do them off the same pin, but I find they work real well. Although they don't work as well as those old Polaroid high power things.
Yeah.
But they're a lot easier to use and they're a lot cheaper. The Polaroid, it's like 6 wires to control the thing, and you have blanking signals and you have blanking inhibits, and there's a lot of this,
Oops.
I've actually had pretty good luck with the ones I've been buying. I haven't been going to China for them. I've been buying them from Pyborg. They have an HC SR04, and I've been buying mine from them and then running it on their Ultraborg board, which has a sonar built into it. And I just checked to make sure what my delay was, but I'm doing a sweep, and it looks like on my sweep, I'm only doing a 100 millisecond delay between pulses. So, and I don't remember having any problem. It would actually do a fairly smooth sweep at 100 millisecond stops per sweep per 5 degrees.
Yeah, so you're going slower than you have to. I mean, you can, again, I found that I can reliably ping them at 40 milliseconds, all the sensors I have. Again, some of them I could do faster if I wanted to push it. I just don't want to push my luck too much. So in 100 milliseconds, you're going slow.
No, wait a minute. I'm wrong. The delay was 0.01 seconds.
Oh, 10 milliseconds?
Yeah.
You're
0.01.
You're pinging the same sensor at 100 hertz.
I do a ping. And then I wait. I do actually. Oh, hold on. I know. I just realized. I do a ping, let it finish, and then I wait at 10 milliseconds.
Okay, that's different.
Yeah, that makes more sense.
Hey, David Anderson, were you pulling our legs when you said the big Polaroid sensors could see a single human hair?
I tell you, they can see a lot of things that these sensors can't see, and I would list among those things these sensors can't see that those Polaroid sensors can see are soft cloth, foliage if you're outdoors, chain link fences. You get good reflections off chain link fences. So pretty much the only robots I've used these others on are indoor robots where the range is short. Also, those they're advertised to see, those Polaroid are advertised at SenseComp, they're called now, that they can see up to 32 feet, but I've never found one. I've tested them pretty extensively. I think a more honest marketing figure would be 25 feet. And I would say that they're most reliable within 16 feet. So half of what they're advertised for.
Yeah.
On the other hand, something that's 16 feet away from your robot is a long way away in terms of maneuvering or whatever else you want to do. That's a long way away. If you could see out to 100 feet, what would you do with that information? Well,
yeah, but it's also a bit of a problem sometimes, right? Because if it's so sensitive that it can pick up that echo after that much time, and it has sort of been attenuated by that much, that kind of means you can ping it only very slowly, right? Because you gotta really wait until that echo has come back.
Yeah. So if you think the speed of sound at sea level, which is more or less where we are, about 1,100 feet per second. So just to make the math easy, let's call that 1,000 feet per second. So that means that's about a foot per millisecond. But you actually have to go there and back. So something that's a foot away will take 2 milliseconds. So something that's 16 feet away will take 32 milliseconds. And if it's 25 feet away, it'll take 50 milliseconds. So you really can't, whatever your maximum target is, basically it starts a timer running at, I think it's running at 400 kilohertz. It starts a timer. And then it says, I'm going to wait for a return. And when I get the return, I stop the timer, and that's how I know how far away it is. But if I don't get a return within 50 milliseconds, I'm just going to report that it's infinitely far away, that I didn't get a return. So you have to potentially wait for no return, which might be as much as 50 milliseconds. So basically, it can't really be scanned any faster than that.
All right, 50 is not too bad, I guess. I was just thinking, could you still get an echo after that?
You know, the way these work is there's actually an amplifier in there that amplifies the return signal. So the longer it takes to come back, the more it turns up the gain to try to get that very remote signal. So I actually have on JBot, there's actually 4 sonars, and they're each pinged in sequence. So that means that I actually am only getting whatever that is, 6 complete cycles per second. That is, all 4 have to get pinged in that amount of time, and potentially any of them might wait as long as 50 milliseconds to say I didn't get a return.
David,
On the other hand, I've not really found that to be a handicap, and basically I'm doing what you're doing, Chris, which is when the control loop comes up and wants another sample, if it's not available, I just take the last one. And that seems to work fine.
David, since you seem to be, as far as I know anyway, the one person who's spent some time with these SenseComp ultrasonics, and everyone else seems to be using cheap ones, could you maybe give us a little overview of what they require for, let's say, a Raspberry Pi or a 5-volt robot? Like, because I've got their website up here, but I can email them. But I was just wondering what you know, how hard would it be to integrate one of theirs into a Raspberry Pi or a 5-volt system?
Well, it's a 5-volt device, and you know,
Okay.
it's got these big chokes on there, so that I think the ping is like 20,000 volts or something like that. Boy, if you put your finger down across the sensor when it pings, you definitely know it, and you can hear it. You know, because when it pings that sensor, it's a broadband signal, and some of that broadband is down in the human audio range, so you hear a kind of sound each time it fires. Driver itself, it's really not that difficult, but basically because you're using the same membrane for transmitting and receiving, there has to be a certain amount of delay between the time you switch modes, because the membrane could still be vibrating from the transmit. And that effectively means that there has to be a dead time in there, and that dead time then boils down to how close you can see an object. And twiddling around and playing with that by hand, I've got it down to about 6 inches. And so you can't really see anything any closer than 6 inches. If you've ever looked at the Nbot robot, you may or may not have noticed that the sonar array is 6 inches back from the front edge of the robot. That's why. So I can see objects that are all the way up to the very front edge. But basically what you do is there's a blanking signal and a blanking inhibit signal. So you pull both of those low, and you set the trigger high, and that starts the ping. And at that point, I start my timer. And then you wait for, I can't remember the exact number, but it's on the order of 12 milliseconds. And then you enable the thing to start listening for the echo return. And again, if the timer times out without getting an echo return, I know that the furthest I can see is 25 feet, so I return 25 feet if I don't get that's my equivalent of Chris's -1.
So do they sell only sensors, or do they also have driver boards?
They sell both, and they
Okay.
have some that are. You have to look carefully. Some of them have a fixed range that you set with a potentiometer. So all you get to tell it is signal me when something is within this range. That's not the kind you want. There's some that have the driver board built into the sensor, little round driver board. The ones I use the 5600 driver board because I've got a bunch of those. Probably have one right here.
Cool. Yeah, because I might like to investigate, because I accidentally blew out the driver on my Ultraborg, and I haven't replaced it yet. So I'm kind of looking at possible solutions.
That's the driver board, and that's from SenseComp. See these big coils here? That's, as I say, that's basically, it's like a little charge pump, and it builds up this, I don't know, it's 2,000 volts or something. I've forgotten. It's enough that you'll notice it if you've got your finger on it.
Okay, cool. Thank you very much.
So David, what about the legend of sensing human hair? Who's that? Were you pulling our legs on that one?
I don't know anything about sensing human hair. I mean, it can see hair. I don't know that it could see a single hair. We were up in Colorado. I turned J-Bot loose in there's a big steep driveway by my folks' cabin, and I turned J-Bot loose in the driveway, and my mother was fascinated on how it was carefully maneuvering around all the little flowers and weeds that were growing up out of the cracks of the driveway. Probably could have just driven over those, but this is a discussion for another day. What's defined as an obstacle when you're outdoors is very different than what's an obstacle when you're indoors. Basically, if you can climb over it, it's not an obstacle.
So speaking of that, I saw it, Heathkit. You all might like to see this. I'm thinking, So let me click. And
Heathkit. I haven't heard
yeah,
that name in a
You
while.
guys, can you
I
hear each
know.
other?
That's why I'm like going. So there's this spot. So
Oh yeah.
so yeah. So does that help you any?
That looks like the kind that Dave mentioned with the circuit board built in, the round one, right?
Right. That's why I'm thinking.
And they're
Based on my-
sourcing those from there, probably. Yeah.
Because yeah.
I think that would be about the right time frame for those sensors when they first came out on Polaroid, when the Hero was out.
It looks like you can actually get it now. They're saying that we go here. That there's some delays on stuff, but anyway, it was in this spot. So if you're interested, might check it out. I don't know what voltage it uses.
The sensor looks like it's 1.5 inches in diameter, so.
Yeah, the TI boards, the sensor was separate from the board. It wasn't on the back of the unit.
So anyway, I just
Heathkit
bumped into
still
that.
alive?
So
I thought Heathkit had died a long time ago.
well, it did, but it sounded like they're trying to come back. If you know,
Somebody bought the brand and they're remarketing some of the more popular things.
Oh,
right?
they're
They don't
done.
have a lot right now. It looks like of choices, but they do
Well,
have that ping pen.
Website for sure. Wow.
Because yeah, when I went down to the robots, what did it click on? Yeah.
Yeah, you can get an LED clock for $125.
Mm.
Right now, yeah, they don't have that many products, but hey, but they do have, it looks like the sensor.
You get an AM radio for $150
That's
Yep.
pretty cool, actually.
if you can
John,
find a
that-
radio station.
If I want
John,
to listen to
that sensor looks like one of the ones that doesn't actually give you back the distance to the object, but rather you set with an analog pot how far away you want an object to be, and it pings continuously and only
Sure.
raises the output line when you're within that. That's not quite it. I mean, you could use that, but that's not quite as useful as being able to actually measure the actual distance.
Okay, well, I just bumped into it, so I'm like, as you were all talking about that. So, FYI info hours.
I could tell you another thing, just FYI for anybody who's interested. These things they have a choke on them that's tuned at the factory, and the wiring harness that comes with it is part of that tuning. So that is to say, let's see if I can unwrap it here. This wire comes with the connectors to hook up to the. Can you see it? Okay, so you don't want to like cut that wire and put a connector on it because you'll detune it.
Wow.
Yes. So whatever length that is, that's what you're stuck with. The sensor's got to be that close to this little board. And if you want to make a slick design so you can take your front bumper off and just unhook it, don't do that. That would be bad.
People might find this interesting.
I don't know if you can see here. There's a pair of those on the RCAT, and those are the driver boards. Here and here, you can see them laying down. And then the rest of that excess wire, you see, I just have doubled back and forth across the bumper, so it acts as a little spring there to keep from changing those. But you need to leave that wire the length it came from the factory.
Another sensor that ultrasonic that hasn't been mentioned is the Maxbotics one. I don't have much experience with it, but I've looked at them several times in the past. Seem to be pretty good. They come in a variety of different ranges and just width of field of view, and they tend to be around 30 or 40 bucks a piece.
Yeah, Ted, I've got a couple of those, and I was putting them on an outdoor rover, and I was listening. I did an internet search and said, oh, you need this type if you want it on an outdoor rover, and I bought them, and those were not the right ones to get. And that's kind of the problem is you need to really know, they have so many sensitivity variations, and the ones I've got are the less sensitive for noise and stuff. I think I would have been better off if I'd have picked some up that were a little more sensitive. I thought people might be interested in this. Let me see if I can share this.
Are those the ones Lulu sells?
I think they sell them too. Let me find what I was going to show. Yeah, I thought people might like, since we were talking about an oscilloscope and everything. This is a foil out of one of our training decks. And so you can see on the trigger, here's the 10 microsecond pulse. That's the trigger pulse. And there's a delay, and then there's 8. The transmitter makes 8 spike pulses. And this is where the power that's sent out is. And then this is the echo pin, and it goes high after these guys complete. And it's following this receiver. And I guess it's when my suspicion is that when it starts increasing from its lower value, when it starts going up again, that's when it gets triggered. And I just thought this was a kind of an interesting exercise, and you guys might like to see what it looked like.
Yeah, that's interesting.
Yeah.
Okay, cool.
Yeah.
Okay, so we're going to switch topics to a hovercraft thing. I can give an update.
Sure. Is that Carl guy? Can do that.
All right, so yeah, I've got it set up with my remote camera this time. So since last week, I've added a display. So now the first 3 lights tell the condition of the IMU, so I can tell if the fusion sensor and the gyro and accelerometer are calibrated. I don't have to go into this other screen, although I can. And but at a glance, the lights tell the status. And then I also added, let's see, last time when we were here, we had this problem there was this kind of glitchy behavior when it was right around 0 or wherever the set point was. So the first thing I did was I fixed that, and I added a mode so that I can make the set point be wherever I want it to be, just by stopping and disabling and re-enabling the pit loop. But you'll see that it's nice and well behaved. Now it doesn't have a glitchy thing. I also increased the gain so it stays put a lot better than it used to before. And then, let's see, there's another interesting thing I found, which is David had mentioned a comment about wanting to have so many samples, so many ticks of the encoder per sample period for the PID loops to close properly. So I thought it'd be interesting to look at that. So like right now, I don't know, okay, you can almost see the, all right, so on the green display, this is showing the number of ticks per sample period, front left, right left of each motor, okay? So if I turn on the PID loop, the heading PID loop, it's locked into the current orientation, whatever that is. And you'll see that as soon as I put it up on a stand, so as soon as I turn it, it tries to correct. So right now, it's trying to do 24 ticks per sample period. So what's interesting is you'll see that as I get it nice close to the set point, it gets really close to the edge, and it gets kind of interesting because the wheels kind of turn at their own independent. They don't all move in sync, right? Because they have different trigger points. So you see how the wheels are moving independently, and it's closed loop. They're bouncing like 1 and 3 ticks per sample period.
And Carl, that's exactly the behavior I was getting in my PID loop. I don't know if you remember that.
Yeah.
It even looked like that.
But the thing is that I don't know. I don't remember if I put a deadband in here or not. But it's really, I mean, it stops. It centers itself pretty well. So if you put it on the table, then I can show you this other mode that I added. So like the loop is on now, right? And if I disturb it, it puts itself back pretty well. Like I do it, it takes the shortest path. It overshot a little bit there, I guess, but it settles in pretty quickly and just stops moving after a moment.
That's
so that
excellent, Carl.
Yeah, it's getting there. And then you like this other part I did too, David, I think. So I had initially designed like this one screen where I can see, I'm just using a PD loop right now. The contrast isn't working so well. But I put the on the pink. So I display the PID values. At one point I was going to make it so that I could use these to drive it off the table. But I could use these to tune the PID loop real time. But to do that, I thought it would be great if it had a kind of a step function change. So I could put it in this other mode here like this, and it just goes back and forth. And that worked out so effectively that I just did that a few times, and then I went into code and hardwired the PD values a little bit up or down, and so that's the mode that it's in right now.
That's great, Carl.
That's Carl. Can you drive forward or backward? What's the slowest you can smoothly drive?
Oh, okay. Well, here, we'll use my voice to keep the thing moving on. It's a little difficult with this really crappy joystick, but like I have these buttons hard coded to 20 ticks per second. But if I want to go by manual, let's see how slow I can get it. And I'll put on green mode. So it's really hard to move it. There. That's 4. That's about 3 or 4. 3 or 4 ticks per second. I mean, ticks per period. But whoops, that's too much. I drove it off the table by accident when I dropped the controller the other day. That was no good. Let's see. I don't know.
I don't think things out of calibration.
Let's reboot it. I'll give it one more try.
And Carl, just out of curiosity, what kind of motors are you using?
It's the ones that came with this kit out of
China.
Mobius Tech at AliExpress. So
the platform itself is a fixed thing, eh?
Yeah, I've covered them up with tape.
Okay.
This is the first I've seen this jumping behavior. I don't know what's going on. It's not good. Let me change the other controller. Just like, let's see how slow we can go. Any better? There. How's that? It's about 2 to 4
The reason
ticks.
that up is because in a differentially steered platform, which is what you have here, when you turn in an arc, the inside wheels will be going very much slower than the outside wheels. And so the ability to go really slowly, real precisely, translates into the ability to steer real precisely.
You know, I totally believe that. And that leads to another thing, which I don't really have the space to demo in here very well, but let's see if I can't show it on the floor, sort of. So,
Getting wobbly, Carl.
getting wobbly. Let's see if I can't sort that. Okay, so here we are on the floor. And I have this mode now, so it's locked in the heading loop. I don't know what the glitch is at first. I have to figure that out. But now when it translates, it'll maintain the heading loop pretty well. So even if I perturb it, it always goes back. And I didn't have a chance to make a video, but
that's very cool.
Yeah, I'm really pleased. I'll do a video for next week and show how well it works on the really rough carpet, because it's dramatic, the difference that it makes. It still isn't able to get back to exactly the same starting point, and that's because I think it really needs a position loop. But just by holding the orientation more constant, it's so much better behaved. And anyhow, now I have enough foundation set that I couldn't finish it for this week, but by next week, I hope to demonstrate spin mode. Spin mode is where it will turn in a constant thing, and then you drive it. It'll be doing your pirouette trick, David, I hope, by the next week.
Cool.
I had a little trigonometry fail again over the weekend. So there's something about trigonometry when the weather is nice and it's the weekend. The trig just doesn't work right. That's my theorem, and I'm sticking with it. I can prove it.
Carl, I think if you put a claw on that, I think it's a Scott Gibson killer. You know, it'd kick his butt.
You know, I've been a little slow to get there. The line follower was in the way, but so after I get the spin mode working next, the spin cycle, that should be very interesting. And then after that comes the actual hover sim thing, where I'll put a layer, a control layer between this and the motors, so that in hover sim mode, it'll behave and respond like the spaceship in the Asteroids game. So you give it the thruster, and it'll keep going until you turn it around and give it thrust in the other direction.
Cool.
So that's the ultimate. That's where I was aiming for a year and a half ago, and well, I'm getting there. And that's my update.
And here's this voice of envy. Are you sharing code?
Yeah, I'd be happy to if you like.
Are you now? You're writing this in C++, aren't you?
Yeah, it's yeah.
Yeah, I would be informative to my attempt set,
Okay.
as I'm now starting into my attempt at the same thing. So I'd be keen to see how you did some of these things.
You know, there's a few caveats. The first is that I'm quite the hacker, and you know, for what I've learned about doing the code relatively cleanly in modular fashion, there's a lot of legacy stuff that I inherited and stumbled through myself. So it's really not in a perfect form yet, but so it's not a public repo, but if you send me your email, I know your email, I'll attach you to that repo, and you're welcome to peruse through it.
You're getting
careful about
It'll give him more of a challenge that way, right?
Careful about those caveats, Carl. had a professor in college, and we were all supposed to show our projects on one day. And the first guy got up and he said, "Well, it's not really complete, and it's not really in the form I want it." And started off with a bunch of excuses. And the professor said, "Well, let's not see it then. Who's next?"
Yeah, no, I understand. Well, that's why I got the demo out of the way first. And this was let the buyer beware, right? It's worth every penny that it's going to cost you, Murray.
Yeah,
Maybe more.
It's only the ideas. I've got to port it over to what I'm doing anyway, but I'm sure that it will be informative, so I much appreciate it.
Yeah, no problem at all. I'll take care of that here in a little bit. I am for as sloppy as it is in spots. I'm kind of proud of it because it's pretty well behaved in a lot of ways. It has some there's still some built-in tests I want to add because like that IMU. So Murray, you had mentioned the BNO 55 or 85 would just lose it. It wouldn't boot up all the time.
Mhm.
Well, I've noticed on this guy that every now and then when I have it running on battery, and then I'll attach the cable to program it, and just touching the shield, it loses calibration and the display screws up. Or sometimes it'll be running around fine on the floor, and I'll pick it up and move it, and all of a sudden my 3 green lights turn red because it lost calibration. So what I need to do is, and I haven't done that part yet, is put some logic in there so that if it loses calibration, it turns off the PID loop. That needs to happen soon.
Does it sound like it's a static kind of problem? Static discharge?
I think so on that case, because it'd be running fine and all of a sudden they just lose it. And then the telling thing is that the LCD display went bad as well. Now I haven't checked to see if the motor PIDs are still running, but the NeoPixels showed that, and the display were just showing that it got into a bad state somehow.
Those plastic rollers may generate a lot of static electricity on a nylon carpet.
Oh, I bet that's quite true. And they certainly pick up air around the axles, I'll tell you that much.
I had a robot that did that, and I finally basically had to drag a little piece of chain underneath the center of the robot.
You gave it a ground strap.
Yeah.
Otherwise, it would touch against something, a metal thing in the room, and it would just die. It just.
Wow. I like that properly grounded robot.
Well, I can say from my experience,
go gasoline trucks, right?
Yeah.
I can say from my experience with the BNO 55, it's plenty mysterious. It would sometimes just lose calibration almost randomly. I mean, it didn't even have to be moving for it to happen. It would just sometimes just go, and just kind of throw its hands up and have a little faint.
Yeah, well, I've seen that too, and that was the final straw for putting the NeoPixel in place because I don't have to go into some buried screen to figure out if it's calibrated or not. It's just big red versus green.
Yeah, I've been using these little 5x5 RGB LED displays, and I've been kind of thinking to do that same kind of thing, is it would just change color. And in fact, I've got the black or the white ones. These are 11x7 LEDs. Yep. And I've just wrote a little thing that actually makes them blink either sideways like wipe, and so I've decided that I'm actually going to have the robot display what it's thinking effectively, like its behaviors and how it changes these displays. But if I go to color, then I could just go like purple when it's or blue when it's in a bad mood, or just show moods through the LEDs. It's a great idea.
Nice. Yeah.
So you gonna have it say like WTF or something, or what? How's it gonna express it?
It actually does say help right now.
Oh, help. Okay.
Yeah, nice. But I really just wanted to have colors or have it and actually it came about from David talking last week about the idea of having the robot do a little up and down or left and right when it came to an elevator. And it was sort of like, you could basically just have it go up and down or left and right as yes and no.
Yeah. So always fun to imbue some human characteristics on these inanimate things.
Yeah.
Then it's somehow more gratifying when you curse at them, right?
And then it says help.
I don't know if anybody saw, I think it was like one of the first few episodes of Modern Family and the husband of the family, or the dad of the family, explained what he thought WTF meant, and he said, "Y'all know what that means, right?" And he said, "Why the face?" So anyway, we went on a tour in Canada, and the tour guide was covering some of the, I guess, acronyms, whatever you want to call them. Anyway, LOL and all that stuff. And I said, "Yeah, you know what WTF means?" And she said, "Don't say that." It's like, why the face? But so that's a perfect one.
That's the family version.
Yeah, yeah. Hey, Chris,
cool.
I got to give you a shout out there. I looked at the code, and for some reason, well, it was older code, and I know I had fixed that in other versions, later versions, but for some reason I still had the encoder variables as statics, not as volatiles, and changing it to volatiles quickly fixed it. You saved me a lot of grief. So, but I thought I had changed it in all the code, but apparently I hadn't. So.
All right. So who else has some static variable issues? Something to talk about?
Yeah.
Uh-oh. Quiet night.
Yeah.
Hey Murray, I'm seeing on GitHub the email that I have for you, something or other 18. That's not on GitHub. Do you have a GitHub account you can mail to me?
I will.
Okay.
Yeah, I use an alias on GitHub.
I figured. Okay. Quiet week. Was everybody getting excited for some combination of outdoor contest and doing other projects, or have we?
Yeah.
It's the nice weather effect, isn't it? Everybody just has to get outside now, since we have those 3 days in Texas when it's not either below zero or above boiling.
I did have one question. I had started playing around with using either an Orange Pi, which turned out to be not a good move, or my Fire 3, a NanoPi Fire 3. And so I built, I've got a carrier board that fits onto my robot. And so I made a duplicate of that so I can just swap out the brain on the robot. So this is an Orange Pi Fire 3 with a little board on top that I use as a breakout board. And I got it running. The only thing is that the I2C bus that is on the Pi that you usually use is bus number 1. And they've moved bus number 1 from pins 3 and 4 or whatever over into the middle of the GPIO. So they, as Orange Pi and everybody seems to do, they claim it's Raspberry Pi compatible, but then they often move the pins around. So the question is, anybody know how to change? Like, I've got all these Pimoroni and Adafruit Python libraries, and they're all expecting to be on bus number 1, I2C bus number 1. Does anybody know how to swap bus numbers? Like, is there some way to, in software, change to bus 0 or bus 5 or bus 8, which is what the other boards have? No. Yeah, I couldn't find an easy way. I dug way down into the libraries, and there's often either a hard-coded or a way to set it, but not from my code. And it's just like, I can't believe they call these things, this is supposed to be Raspberry Pi compatible, but the GPIO bus is a 40-pin bus, but things are in different places. So it's sort of like, eh. And they don't even have the same buses. Like, you can have up to, I think, 8, well, someone correct me, but I think at least 8 I2C buses. But which bus numbers they choose to implement, like the Orange Pi uses 1 and 4, and I think you can turn on 7 and 8. The Pi itself has 0 and 1, and I think maybe 2, but they all use different bus numbers. And I think to myself, the engineers who decide not to use the same bus numbers in the same pin locations as a Pi drives me nuts. So I'm going to have to dig into the code, I guess.
But Murray, it's going to be some totally rational explanation, right? It's going to be because the guy who did the Orange Pi has these 20 other robots that he did, and whenever he did the Orange Pi, he needed to use a different bus number, and that's why it uses it, right? It's going to be something totally market appropriate like that.
Yeah. Well, as I think I might have mentioned before, like this is an Orange Pi, a Pi 4, and it's a really nice board in the sense that it's high power and all this stuff about it's great. And there's also the Banana Pi, and I thought about buying one, but the more you read about these, like the Banana Pi in particular, and I hate to talk dirty around people that I don't know, but apparently most of the forums about the Banana Pi suggest that their support is just about zero. Like their documentation, their support is like none. And Orange Pi seems to like to sell boards, but their documentation and their choice of, I don't even know how you use a board like this. I mean, if you're just going to make it a board with no connections to it, or you're going to make a little computer like a desktop computer, fine, or a server. But if you're actually going to plug things into your I2C bus, half the time you can't get them working. It's really frustrating. I've been trying to find alternatives to the Pi. And like I said, this Fire 3 is great. It's an octo-core, and it actually, surprisingly, I was running my Python code on here. I managed to get it running, my robot operating system, and I've got top running, and I can see that it actually runs all 8 cores. It's pretty cool. So it, and this is a 1.4 or 1.5 gigahertz 8-core processor, and it actually in Python, without me doing anything special, is actually hitting all 8 cores when I do something complicated. And so it would be a really powerful computer. Unfortunately, it only has a gigabyte of RAM. You can't get a 2 or a 4 or an 8 gig. So I think I'm going to end up with a Pi 4 in the end because it's compatible. Compatibility is a big deal,
And support, documentation.
Yep.
I mean, we only have so many boards and time to.
Well, but there's a couple Banana Pi boards that look really good. And then I started looking on the forums about how well they're supported, and everybody, in fact, I challenge anyone to go to the RBN website. RBN is a ARM-based operating system, Linux operating system. And RBN, the guys there, boy, are they nasty. They're mean, and they just talk. They hate the Raspberry Pi, and they will not ever implement the Raspberry Pi in RBN. But then you read further, and their attitudes about some of these boards are well-founded. I don't know about the Raspberry Pi. They don't like the Raspberry Pi Foundation at all. But the Banana Pi comes in for particular harsh treatment just because no one's had any luck with documentation, support, and yet there's thousands of these boards sold, and yet who knows what anyone does with them. So yeah, that's my report on my second report on all my troubles with all these alternate boards. And the best one I found so far is this Fire 3. And if I have figured out where to move the pins for I2C bus number 1, and it does work. I've got this working, and it's the only one I've been able to get working. The rest of them have been a complete failure. Like the Orange Pi, forget it, no way. And the chili and the tomato, no. I'm not making that up.
Chili pie?
This is the chili, and the tomato is a giant board. I thought it was quite small, but I didn't actually look at the RTFM is another one of those. The size of the board, it comes out, it's like about that big, and it's got it's basically a Raspberry Pi with a whole bunch of Arduino compatible pins on the same board. But again, support, very difficult to get the thing running apparently. So yeah. I'm sticking with Pis for now. Or maybe, as David's been pushing me towards ARM computers. It is an ARM computer. We're not going to get into that one again. But to use it as an ARM computer rather than something else.
It's kind of like the Kendrite K210. I mean, kind of minimal support for that. Probably on the opposite end, though, the Expressive 8266 and the ESP32, they've gotten pretty good support. So,
well, I've got 2 of those ESP32s on their way. I've got the Pico and the Feather. Same designer. One guy, I think he's German or something. He's designed 2 of these boards. The Adafruit and Pimoroni are both selling, and they came with really good reviews. And they are actually a nice small, high-powered Arduino-like board, and I might try building. With David constantly pushing me in the side of the head, I may try to build a robot around one of those.
Ray,
Yeah.
have you played with that ESP device?
Say that again?
Have you played with that ESP device?
Yeah. Mainly the ones that have the LoRa transceiver on them.
Oh yeah.
What is your What are your thoughts?
You know, it's they're for what you get on those boards. You know, you have a LoRa transceiver. They have Wi-Fi, Bluetooth, 240 megahertz dual core. For the price, it's really pretty good. Even with the LCD on it, you still have quite a few pins that you can use for other things. The OLED is I2C, and the LoRa transceiver is SPI, so it takes up two of those interfaces. But you can pretty much make any pin a PWM pin if you want. There's several analog pins. That's one thing. The A to D converter, they may say it's 12 bits, but it's not linear at the bottom and the top of the scale. So it's maybe 12 bits if you knock off, a tenth of a volt on either end. So, don't plan on measuring anything less than 0.1 volts or 3.2 volts, I guess. So higher than 3.2. But other than that, the support seems pretty good. I mean, you can, if you want to use the Arduino IDE, you can. It seems like, you can use Platform IO if you want to. There's tons of tutorials out there, kind of explaining how to hook up various things to it and do different things.
And are you coding in C?
Yeah. Yep. So pretty good, I guess, for what you get. One of them on the first set that I got, one of the LCDs was cracked, and Banggood is making me bend over backwards. I sent a photo of the display. The first, I think, 10 lines, every other line works. And, I took a very detailed photo to show where the glass was cracked. And they say, oh, please send a video. Not enough information. It's kind of like, oh, come on. You got everything you need here. Just send me another device. So,
I think that I've dealt with that sort of thing. I think they figure if they finally exhaust you, you'll give up.
You'll give up. Yeah, that's probably it. Yeah. Or, some time period will run out. Oh, we didn't get your information soon enough. So, but yeah, I think they're very good devices.
On that ESP32 device, I used the Wi-Fi version. I had the idea about this, using it as a home security monitoring tool. I don't know if you guys remember.
Yeah.
So I implemented it, but basically it's monitoring the channels, and there's a Max multiplexer there to monitor all the channels. But I think over a year, 2 just failed. I mean, I don't know why they failed, but I think just the chip, I guess it's powered, it's always running, but it basically failed. So I thought, well, it's not gonna be a product anyway. But yeah, that's what I decided. I'm not gonna really touch hardware.
Oh, that's disappointing, huh? Yeah, I haven't heard of anybody, having chips that just failed. So.
Well, part of the interest for me on the ESP32 is that it does run MicroPython. And so I can, in theory, I'm not sure it'll support all the libraries that I'm using, but in theory, I could support at least a subset of what I've written for my Pi-based bots over onto an ESP32, and then take it all down onto this, they're calling it I think it's a Feather S2. So it's an ESP32 based chip in a Feather form. And, it's a tiny chip, 240 megahertz. It's not as fast as 1.4 gigahertz 4-core, but, maybe I don't need that if I don't have Linux, right? So the idea is port everything over and see if I can get running in MicroPython, which would be an interesting challenge. because everything
Yeah.
I've got is Python, so it should work.
Mhm.
I can't do Circuit Python, I don't think, but a MicroPython's a real possibility.
Yeah. Yeah.
Yeah,
Yeah. And
my
I think
tendency
anything's
is
got a bunch
if
of
something
tutorials.
works, yeah, I was gonna say if something works, my tendency is I'll stick to that hardware as long as I can.
Yeah, sure.
Unless, unless something I just can't use it anymore. But
Well,
yeah,
I've had
more
those
software
little
preference.
I've had those little Raspberry Pi 0W based security cameras plugged in around my house now for I think 5 or 6 years, and they run 24/7, and I've got 5 of them, and they're running all the time, and they don't ever break. I mean, it's it's like one of the few things in my life that hasn't broken. I mean,
Yeah.
I've got this. By the way, I've got this thing behind me. This I don't know if you can see it, but it's a MacBook 12-inch, and it's been spinning its little black thing around for the last 5 or 6 hours, and it's theoretically installing the operating system for the 3rd or 4th time. I'm not pleased, but those little Raspberry Pis, yay, they're still going.
And it's not hundreds of dollars, you know. It's
Yeah, yeah. $40 versus like 1,000 or not 1,000. I think I bought that thing for yeah, I don't remember how much I paid for that thing. It's a lot of money. But
yeah. Apple's just seem way.
Knew it
over.
was for sure.
well, I love it as a form factor. It's a beautiful little laptop when it works.
When it works.
Yeah, it's my favorite laptop when it
When
works.
it works.
Yeah. Oh.
Yeah.
And I apologize for my rant on the mailing list about DF Robot, kind of. It's not the first time I've run across those guys, though, is that I bought one of those little microwave sensors from them, and it died in the first week or so. And when I emailed them, their response was, it didn't cost you very much money. So what? I was like, hold on a second. So yeah, I've decided not to do business with someone who has no support. So I should have learned the first time. But by the way, if you guys have been on AliExpress and all that, you'll know that there's a whole bunch of microwave sensors up there, and they go from little boards about that big all the way up to maybe twice that size. Has anyone played with those? I think about ordering one. They look kind of cool.
I know
Haven't
Andre
taken it
Spice he reviewed a bunch of those. He's put out hundreds of videos.
Oh.
So you might want to look at that. He's
What's
the
his
guy,
name?
the guy with the Swiss accent.
Oh, yeah, yeah.
Andre Spies, I think.
Andreas Spies.
Spies.
Okay. I'm butchering
I know who you're talking about. The guy with the funny European accent.
Yeah.
Maybe I should create my own channel. The guy with the German accent.
The guy with the
Yeah.
German. Yeah.
Oh, Chris, are you German? I thought you were Australian.
I am.
I thought you were Australian.
Yeah, that's an Australian accent. Du spreekt Deutsch.
So what part of Germany are you from?
Let's just say close to Munich.
Oh, that's
Oh,
one of my
okay.
favorite cities.
Mhm.
Yeah, my wife used to work for SAP, which they have their headquarters in Waldorf, and Heidelberg was close by, and she used to stay in Heidelberg all the time. So she spent a lot of time in Germany and a lot of time in the UK, where she worked with one of the vendors who basically, wrote the whole website for education products, and so I got to go over a couple times.
Yeah, I haven't been in a while, so it's time.
Yeah.
Well, I from New Zealand, you can spend about 2,400 New Zealand dollars, and Lufthansa, the German airlines, has for I think over 30 years sold a round the world trip for about I think it's over 1,800 or 1,900 US, and I've done this now 4 times, and you fly around the world, either the north, the middle, or the south band, and you can stop as many times as you like, as long as you keep going the same direction, and you pay any additional flights to change bands and things like that. But I've been to Munich, I think now 3 times, and Japan a few 4 or 5 times now, and Canada, all on the same flight.
Wow.
Same fare. Yeah, it's the round the world fare from Lufthansa. It's a great trip.
So $1,800.
Probably.
It's something like they have sales. It's been going since the 60s or 70s.
Wow.
My
Chris,
problem with Lufthansa is
How
they
long can
always
you
strike.
stay?
Chris, are your parents still in Germany?
Yes.
So, and because you had mentioned when we were talking about transmission delays, about having difficulty talking where the two delays are not equal length, where one is longer than the other. So that's when you're phoning home.
Yeah. No, and I just mentioned they haven't gotten used to that yet. Well, maybe they're getting slowly, but it's, we are sort of experiencing these delays all, every day, right? Sort of almost. But for them, it's they're used to. When I first came to the U.S., everything was still landline. AT&T. Under the ocean wire. Maybe multiplex. There was some multiplexing going on. If you didn't speak for 200 milliseconds, right, they would switch. They would give someone else the line, and you could kind of hear that. But there was no delay. There was no delay. Not much. I mean, not much.
I know if you call another cell phone and then put one up to each ear, both yours and the one you've called, the delay is enough that it's almost impossible to speak.
Yeah.
This goes back to, I was talking about working with musicians about what was an acceptable delay. And as the delay would get longer and longer, eventually they just say, I can't do this, and I don't know how much of that is something you could learn, and how much of it is, as I mentioned before, organists are used to, especially pipe organists, they're used to a long delay between when they push the button down and when the pipe organ resonates. But a drummer, a snare drummer, something like that, if it got really in excess of 5 milliseconds, they would start complaining. They'd say, I can't play like.
Chris, have you ever been to Nuremberg?
Yes, it's actually not. It's only like an hour and a half from where I live. So Munich is a little south. Nuremberg is I'm just in between Nuremberg of Munich, basically.
Oh, okay. Yeah, that was one of the places that we went to, and you go to look like a very old church, maybe several hundred years old, and there'd be a plaque on the side of the wall that said it was reconstructed in 1950. Apparently, it was just bombed to smithereens, and it kept the same city plan, the street layouts and.
Oh yeah, I mean the whole place was in shambles. I mean it's they had to rebuild everything, which in a way, if you think about it, can be an advantage if you have to start over from scratch and rebuild everything, right? Because you end up with a lot of new infrastructure. I mean, relatively new. So.
Oh, that's true. Yeah. Yeah. They said the town had lots of tunnels, and I guess they wanted to try to preserve those as well. So, but
Were you from Ingolstadt?
That's correct. I'm from a small village, 10 miles or less than 10 miles from Ingolstadt.
Okay.
Yeah.
How far is that from Stuttgart?
Ooh, I'm gonna say.
It's pretty far.
I'm gonna have to guesstimate 3 hours. Honestly, my geography is not that great.
So it'd be sort of like driving from Dallas to Austin.
That would be my guess, but it could be off by a little bit. I really have to look at the map. Haven't been to Stuttgart much, so I don't know for sure.
I hung out there.
All in all, it's a small place, right? I mean, it's like my parents would complain, oh, they have to go to Munich. I mean, that's an hour and 15 minutes away. Oh my God, it's like you'd like drive there once a year, and that would already be too much, right?
You have to pack a lunch.
Every time I had to pick someone up who's visiting from the airport, I gotta drive, 2.5 hours to the, JFK airport in Newark or whatever, right? I mean, it's different scale.
I noticed this when we moved back up here to Denton. Denton's a small town, 100,000 people. When we lived in Dallas, everything's about 20 minutes away in Dallas. No matter what you want to do, you want to go to the grocery store, anything, it's about 20 minutes away. And so Denton's only about 40 minutes away. So if you live in Dallas, Denton is not very far away. But if you live in Denton, Dallas is a long way away. You have to make plans, you know.
Yeah, I was in Israel one time, and I had to go from one city to another, and they thought, "Oh my goodness, you had to go 40 miles? Goodness gracious!" Of course, then again, the country is only about 40 miles wide.
Well, I live in a town of 1,500, and it's about 35-minute train ride into Wellington, and about a 45-minute. No, it's about an hour to get to the airport because it's on the other side of town. And now that I'm outside of Wellington, because I actually lived in Wellington, I don't go into Wellington unless I have to. And so I live in a town of 1,500 people, and we basically do our grocery shopping around here. And the idea of going 40 minutes away into a big city of like 300,000, we just don't do it if we don't have to. It's too much trouble.
Yeah, that's exactly what I was describing. If I'm in Dallas, you're going downtown, drop me by SMU. You know, that's 10 minutes out of the way. Oh, sure, I could do that. If you're in Denton, you're going out to the university, and you drop me by downtown. Oh, I'm not going through downtown. That's 3-4 minutes out of the way.
It's all relative. I gotta head out, guys, and it's very unlikely I'll be in next week. I've got some stuff happening around here, so I'll see you probably in 2 weeks, hopefully.
Right?
Yeah, I gotta go too, actually. All right, bye,
Yeah,
guys.
me too.
All right.
Good
You
night.
guys have a great night, and we'll catch
Yep.
you wherever we can catch next week.
Yeah,
Good luck. Build more robots. Bye.
Night all.
Bye now.